Great. So good afternoon. I am Anto Budiarjo. Welcome to Monday Live. This is something that we do every Monday afternoon at 3 p.m. to figure out what the future is for smart buildings. Just in case you wonder who we are, we're listed on mondaylive.org. Head over there and find our links to our profiles. Just a reminder that views expressed here are personal, not of any company or organization. And let's post comments and questions on the Zoom chat so we can make this interactive. And also just a reminder, the slide deck is available on mondaylive.org as well. We may be a little light because there's a lot of travel going on. A lot of people are on their way to RealCom. I will be as soon as Monday Live is over. So we should still have a good conversation today. So our theme for the month is networks or smarter networks, as we're sort of framing it. And the agenda today, normal chit chat for a bit, and then we'll talk about networks, specifically about IP, the Internet Protocol. And the way we kind of want to frame it is really sort of discussing the pros and cons of IP in the context of buildings, obviously, not generally, because that's our focus. And then see where that goes. But before we get into that, hand it over to Ken. What's going on, Ken?
Thanks, Anto. We've got our article online, Navigating the Noise of the New Era. It's getting good reception. How do we navigate the unknown, the never land of what has not been done before with new tools we've never used? And to write this article, I used Bing's AI-powered Copilot to give me some help and some validation, and it worked very well. So it's interesting. AI is affecting all of our lives. So when I finally death do us part from this industry, I may be written by an AI Copilot, and you won't even know I'm gone. There we go. Control cons, we've got the recap, and they've recorded their whole session and they're giving it away, so you can just click on and see what the sessions were all about. There's some really good speakers there, some really good thought. There's some great uses of ChatGPT, how it's going to change our industry. Really good stuff. For the Haystack, I was unable to make Haystack, but Eric was there and did some great interviews as always. What I did is I went through and just made a collection of some of the social media information about Haystack. And I kind of wondered if that was useful. It was kind of useful to me, but wondered if it was a use, but it's actually getting a reasonable amount of reads and support. The problem with the social media, and especially LinkedIn, is it's so time sensitive that everybody posts when the thought's in their head, and the hashtags somewhat tie it together, but when you try and unravel it after an event, I find it quite confusing, and I kind of try and work with this stuff every day. So maybe there is some use in just making summaries of some of these events, so we can at least catch the highlights. Anyway, I was surprised by that. We just had an article just come in just a few hours ago on ignoring TikTok at our peril. This is a real, I think, an angly one, because TikTok is a powerful medium, but it's getting a lot of pressure from how safe it is and what's going on there. So it's interesting, but I think we all agree that the short video format is the key. I think that is, we're going more and more, we're seeing that video and little chit chats are being used. So that's the medium of the future. That being said, my keynote is linked to both the my article, Navigating the Noise, and to the Control Con recap. So read Automated Buildings. Back to you, Anto.
Great. Thank you, Ken. Coalition update. Rick is not here because he's traveling. He's in Ireland, of all places, for his daughter's wedding. So wish all of that, wish him and the family well. This is actually not much different to last week, other than there is now a page for the webinar that is going to be held on 2 weeks from now, on the 27th, and I'm actually going to post the link on chat, make sure that everybody has it. Oops, that's not right. I'll do it once I stop talking. I'll do that. So that's the first webinar from the coalition, focusing on the young professionals and what that group's doing in the coalition. Beyond that, I had a couple of things that I saw this interesting. First, on the left is New York. After it's actually they've been working on this for quite a long time, several decades, I think, to actually implement congestion charging downtown of Manhattan. It's going to start soon, presumably a year or whatever. So that'll be interesting to see how that's going to impact Manhattan. Obviously, the reason I put this here is that we've been talking about what's going to happen to city centers and downtown areas given the changes in the use of real estate. So this is kind of part of that. Exactly how it relates, I'm not totally sure, but it'll be interesting to watch that. I know that congestion charging in itself as a concept works really well. I recall London when it went into congestion charging. You know, one day you couldn't get a parking spot anywhere in London, central London, and after it, there was just parking meters everywhere that you can park because nobody was going to London, which is great. 7.1 miles per hour average car travel in downtown Manhattan, which is obviously crazy stats. The second thing I came up with is this. Obviously, somebody's looking at using nature and sort of learning from nature, and this is all to do with mounds of termites building their house. I guess they're building their what they would think as a building, and some scientists sort of looking at how to replicate that. Right, so that in itself is not interesting for this group, except for this highlighted section here. That the thinking here is that to actually make this work, you actually need a whole bunch of sensors and actuators, which obviously in nature that's being taken care of by the termites. But here they're alluding that is something that technology can help with. So I don't know, just an interesting way to think about regulating a climate inside a building. So those are the two, the community board, link board, that's still there. I think that's been updated a little bit, but just in case you want anything, it's there. Any other thoughts or
yeah, I'd like Anto, I'd like to weigh in on last week's Haystack Connect event.
Please, yeah.
So I think those of us who are panelists know that I sort of re-entered the industry a couple of years ago after departing Tritium in 2012. And it's about 10, maybe a little 11, 12 years since Haystack got launched as an idea. And this event, this year's conference, which took place in Nashville, you could argue was a bit of a milestone in terms of the longevity of the project and and how it's faring. For me, I came in with a real fresh set of eyes and was impressed on multiple levels. Haystack now is estimated to have over 80,000 instances of buildings around the globe that are using the technology, which is still still relatively speaking a small number. I think the very important part were the OEMs that were participating. So besides Tritium, you had Siemens, you had Johnson Controls, you had two visions of Siemens, actually, their J2, which they had recently acquired, and then their conventional or their traditional branch product group. And then there were a number of lesser known OEMs that were also at the show. But the mood and the feeling that I took away was one of remarkable collaboration without being forced into it. This is a choice that the OEMs are making. They're not doing this out of a sense of, well, ASHRAE is saying we've got to do BACnet, therefore we all got to do BACnet. They're doing this because when you look at, they recognize the fundamental opportunity that our industry has in front of it. Less than 20% of all buildings have a building automation system, despite doing this now for 40 years. So there's a huge untapped market. And on Monday Live, we talk a lot about what is it going to take to open up our market. And one of the things for sure is making these systems such that you can connect to them. And early on, today a lot of our conversation is going to be around IP networks, right? Well, historically, the first networks were all RS-45 and put us in a whole different world, and we're now moving into with IP-based protocols. And Haystack actually doesn't care one way or the other, but it's being made available and being seen as a result of IP networks. So that's I think the fundamental shift that I recognize. But again, to be able to move to this world that we want to move into, where these systems are far more easy to integrate to access, and then to have that data available so that we can do something with it quickly at a relatively low cost. Haystack has been, I think, a very successful endeavor. And I just saw a lot of momentum among the participants, and particularly individuals who are largely very technically oriented and see and understand what needs to be done. And it's a community, it's an all volunteer community. And I encourage anybody who's listening today, if you're not involved with Haystack, please consider it. The input is welcome. There are multiple areas in which you can contribute. There's a whole new effort called ZETO that has to do with validating. How do we validate that one Haystack implementation is as good as the next? How do we do that? If you think about how BTL works for BACnet, ZETO is going to be a way to do that for Haystack. And again, it could use some contributions from others. So that's my thoughts, is that Monday Live is about moving this industry forward, and I'm giving my 2 thumbs up to what Haystack's doing to help that overall initiative.
Great, thanks, thanks, Steve. I was also at Haystack. I had the opportunity of speaking on behalf of both Monday Live and the coalition in presenting the cloud native sort of vision that we have collectively on the IBB. So I thought that was well received. In fact, it was done as part of the Pitch Fest, and it was interesting that I think over half of the pitches that were being presented there at the Pitch Fest were about cloud in some way, shape, or form. Right? So I thought that was very interesting. I echo what you're saying, Steve, about the community, and I've been to like a couple of other Haystack Connects. And I felt that what I saw last week was very, not quite sure what the word is, but it was sort of heads down, getting into trying to figure out all of the collaboration that needs to happen, and just get down and actually getting stuff done, getting stuff implemented and working. So I thought that's sort of a good progression in terms of the project, because obviously in early days it's trying to create the vision and the concepts, but very operationalized. That's kind of the word that comes to mind. So that was my take on Nashville.
That's appreciate the feedback, Steve and Anto, because I was debating on Go, but I think it gives me a lot of confidence in where Haystack is. We're still doing a big bet on Haystack and what we're doing, but it's good to hear that that's kind of where the next phases are moving into.
Yeah, cool. Any other thoughts or comments before we move on? Hearing none. So smarter networks. And what's going on here? All right, sorry, I had a little tech hiccup. Right, so we talked about networks generally last week, and for this week, we really want to focus on IP. And just to remind everybody, IP is right there in layer 3 of the 7-layer OSI model, right? So that's our focus for this week. So we're not really talking about the physical or the application layers at the top. We're talking about something that is, I think, core to networking today as we think about it. I mean, listening to Ken and Steve talk, IP has obviously changed this industry significantly, right? So that's kind of our focus today. And the way we want to frame it, as I mentioned earlier, is really just the pros, what's good and what's bad about it, the pros and cons. Again, specifically for buildings, not so much for IP in general and general networking, but for buildings. Like to start it there and open it up for conversations, and obviously always love to get thoughts and comments from the audience. And if you want to chime in live, just say so, and we'll make sure that we can make that happen. So any immediate thoughts as to good and bad of IP? Anyone want to start?
I hate to live in a world of good and bad, right and wrong. It's almost like so good and bad, useful, not useful. To me, that's the way to look at it. Useful, not secure, not secure. Good and bad, just a bunch of opinions, people selling stuff. Useful, not useful, secure, not secure. Doesn't make sense for our industry.
Yep, I can support that, Bill. I think because to your point, it's whether it's you, because it could also be useful to you and not useful to someone else, right? At the end of the day, so it's not that it's good or bad. Is it useful to what you're doing and what's specific to your application solution?
Mm-hmm. And I know all those IoT people that came here into the industry, flooded the industry. What they think. So
That's right. Those buggers.
Yeah. So from a useful standpoint, I think the main driver for, if you will, for going to IP in general is to make these systems accessible with off-the-shelf tools and applications. So when I say tools, I mean your laptop, your phone, your tablet, etc. Because everything from an IT perspective is all based on the IP protocol. So that clearly is a huge driver, and everything cloud is IP. So the architecture has, as we've talked previously, has expanded to include any type of cloud connection. So it was effectively inevitable that we were going to move in this direction to our OT networks becoming increasingly dependent on or incorporating IP into them. It's not like they haven't had some way to do that. There've been IP to 45 gateways for some time now, so that part's not new in terms of trying to get to an IP device, device. However, now what we're seeing is that it's not just the one network controller or supervisory controller that's IP based, but all of the unitaries are now moving to IP as well. And so I'd love to hear, particularly from you, Anno, and Tracy, how you view all the unitaries moving to IP and whether that's useful or not. But certainly that's what we're increasingly seeing as the manufacturers move in that direction. But from a useful perspective, it's the devices that we want to have, the accessibility, the ability to move data from the building to the cloud and back and forth. And that it's not just the movement of the data, but being able to do it, to manage that data in methods that are well known, well understood, and well supported, with the people that are involved in developing these technologies. In other words, the software engineers that you would hire, the network engineers that you hire, they're being trained in the world of IP. So, that's clearly important. So,
Yeah.
I'll stop there and let some of the others start to pick up from maybe what I just kicked off here.
I'll echo on the training side, it's a little bit like, was it Southwest, right? When they went to only 1 or 2 planes, or I think, or 1 model of plane. And they did that because, they trained every engineer, every pilot on that 1 model. And it was just a huge cost savings to them, instead of supporting multiple different manufacturer models of planes. And Southwest has got a great case study they write up about, what the benefits with that. And you could parallel off that. I mean, the other thing I think that's happened with the adoption of IP is the tools that the technicians have available, right? There's just a huge slew of tools around these days that makes diagnosing IP-based solutions much more easier than it was in my day when it first came around, right? I mean, the tools were pretty poor, and compared to proprietary tools. Every engineer likes to grab something free off the web to debug an issue, before they
case in point, if you're looking at you just want to look at what's on the network, you can pick up Nmap, which is free of charge. You want to inspect the packets, pick up PCAP, free of charge.
Right.
So these are just standard tools that anybody can get. And you may not have the training, but the training is easily available. It's all over the place now, right?
Yeah.
So you can move in those directions without a whole lot of resistance.
And then the community around it, right? I mean, anybody can get onto the net, and from a community, you can pitch a question anywhere, in any of the support forums, and you'll get a lot of people coming on helping you from a support perspective.
So IP runs the internet, and the internet is everything, and therefore it is a big network. It's the scalability has been proven, the IP technology has been proven, and the internet, and that has created all of the resources, people as well as tools, making IP a sort of a no-brainer in terms of being able to apply it in buildings. That's the
I'd go one further, even say that I don't know of anything inherently in IP that is a restriction to make it, to do something that we're not doing, right? So the question would be, if it was an IP, the usual answer is, well, I've got a better thing that does these things better. I can't think of anything that IP doesn't do that we don't need today or hasn't solved today.
Okay, so that's on the red side, on the not so helpful. And I would actually say there is one thing, not that I can point to something that we have that is better, but I think one thing that's inherent about IP that's not great is that it is not inherently zero trust. It is inherently open, right? If I know, if I'm as a node, I can ping, I can make requests to another node anywhere in the network, anywhere in the world, and it will do that. And that's its feature. That's not, and that there is no zero trust mechanism at that level.
At that level, yeah.
At that level. So, and we've had to obviously build layers of technology to sit on top of that, right? And one could probably argue that if they thought about this at the beginning, back in the 80s, they may have done something different, but we can't go back in the time machine. But to me, that's sort of an inherent downside, as it were, to IP.
I mean, you call it a bug, others might call it a feature.
Well, it is a feature. The feature is that you can connect to any other node unrestricted. And that
Yep.
is the feature, but it's also a downside because you can connect to everything, and therefore you don't know who's going to come connecting to you, and you can't run a secure application environment with that sort of with that in mind. You have to make sure it's secure. That's why the zero trust sort of layers have been created.
Or-
Let me throw out a couple of traditional arguments against using IP everywhere. Excuse me. You know, some of the things I've always heard over the years, the deployment of internet to end use devices is a little bit more expensive, right? You've got point-to-point wiring coming back to and from all these devices and so forth. There are applications that need a little bit more determinism in the networking and communication, even in some of the more traditional stuff occasionally. Certainly when you start to cross over to things that look more industrial in nature, that becomes an issue sometimes.
You mean like timing, things like that?
Yeah. You know, if you think about manufacturing,
But sorry to be the OSI 7-layer stack police. That's not an IP issue. That's actually a physical issue.
and that's the trade-off here, right? So a lot of people, when they think about, and by the way, I remember doing an interview about 25 years ago, almost 30 years ago now, where I said, within the next 5 years, everything in buildings is going to be IP down to the light switches and all the centers and all the sensors. And I kept every year saying, well, you know, it's just slid out a year. It's just slid out a year, and we're still not quite there yet, are we? So I think overall it's the right direction, and we're starting to hit critical mass and all the things that you guys are talking about in terms of resources and support in the industry and so forth. But there are still some legitimate engineering choices to be made as to, does it make sense to, how far down in the stack do you deploy that, right? Some people, when you say IP, they think of a temp sensor with an Ethernet chip on it. Does that make sense? Well, in some cases, maybe, and others certainly not. So I think that's part of what we should clarify a little bit in this conversation is how, from a physical deployment standpoint, how far are we talking here when we talk about IP networks as the solution?
So just not to have an answer, but to sort of extend that discussion a little bit. And the original arguments against having it down at the lowest level, of course, was the tech wasn't capable of supporting it, right? The chips and an IP stack is actually not a light stack. It's not a light protocol. It wasn't designed for IoT temperature sensors. Having said that, I mean, the processes that we are getting today and the capabilities that we've got today, and, some of these micro devices with the memories and the stuff today, more than happily handle it. It blows me away that I can get this little ESP32 modules, for $5. That's got full IP stack with cyber, with Wi-Fi, with Ethernet, capabilities that you can buy now for $5. 10 years ago, yeah, that wasn't an option, right? So I think the technology question has been dealt with. So now it really comes down to, does it make sense, right?
I really think what I said 30 years ago, we're on the precipice of falling over the cliff of no return here, right? The chips are cheap. The knowledge base is high. The pervasiveness of Wi-Fi and cell networks makes it much more practical to deploy. And wireless, when you mix with the wireless versions of IP in there, right? So I would find it hard to believe that anyone could come up with a valid argument that said, no, we're not headed there. We're going to stay doing this hybrid sort of mix of networking technologies for some time now. I think it's just a matter of of OEMs and so forth, kind of catching up with their designs and getting the right chipsets solidified and a few more. I think there are a few more holes to plug in terms of standards, to Steve's point, you know, with Haystack and what it's doing is a perfect example of that. So we're all but there,
Yeah,
and the momentum is going at such a rate that I don't see it ever turning direction, just accelerating in a snowball kind of a fashion at this point.
So Anna, you were talking about the IP stack is complex. I'm not sure if that was the word.
it's
you
it's
used.
not complex. I wouldn't call it complex. It's
There's a lot of it. There's a lot of it.
it's heavy. Yeah,
It's heavy. Okay.
it's heavy
So-
compared to a lot of the lighter form IoT protocols that you could do.
So is there risk there? Is there technology debt as
Yeah, that's a good question. But I think, again, to Tracy's point, I think that has been answered a little bit. I mean, the IP protocol stack has evolved over the years as well and continues to do so. I mean, it's like any good software development. The IP stacks, if you go out there are better ones than others. You know, there are ones that I would go get that I would trust versus, you know, there's the cheap off the ones direct from China that might not want to trust. Still does IP. So, you know, you as a developer, you have to do the right work into picking the right stack that's secure and as good as it can be.
To that point too, you know, one of the things really working in our industry's favor is the general acceptance
Yeah.
of IoT as a concept, and the understanding that not everything that goes over the internet is a video file or an audio file or a gigabyte size file, right? So there is a lot more being built in at lower and lower levels in these stacks for small message handling and so forth, and more determinism, things of that nature. So like I said, I think that the momentum is just, you know, there now. This conversation, even 5 years from now, it'll be, hey, remember back in the days when we had BACnet chips and Lawnworks chips and, you know, Modbus chips and things. So I think,
Tracy,
go ahead.
Trace, I hear your enthusiasm. It sounds like you from 30 years ago, by the way. So the question is, we all know that the IP buildings that are IP enabled are few and far apart to this day. What's holding it back? Is it the manufacturers who still have all this technical debt? Is it the controls contractors who are afraid of it? What is it?
I think it's just legacy, Bill. I mean, people don't change out stuff if it works, right? I mean, again,
That's one of the characteristics of our industry that is so weird and different compared to most everything else in electronics. And we've touched on this a couple of times in this group, is the longevity of our electronics and our systems is like nothing else out there. I mean, if you think automotive or cell phones or consumer electronics, or it's hard to find many applications, many verticals that say, hey, when I deploy this, I expect this to be there in that building anywhere from 10 years to 30 years.
Yeah.
Right.
Yeah.
I mean, the very fact that I know several manufacturers who have a thriving pneumatics business tells you about what our problem is right there, right?
Yeah, it's funny. I've got a 10-year-old iPad and works fine. I just can't download anything new. The browser doesn't support half the new applications that I want to gain access to. And it's like, I have to go get a new iPad because it's no longer being supported by the technology community.
Yeah.
Right. And so there you go. Right.
Yeah.
It's
Think
it
cell
deserves to
phone.
be, it's ready to go to the museum. It's only 10 years old. In
I
our
have
world, 10 years old is nothing. That's like,
Yeah,
Yeah.
I have a Mac that's kind of like that I called for support. I was trying to upgrade it and they're like, that's what we call a legacy device. It won't take the new OS anymore, you know. So
but
Right.
that's
exactly.
that's the same. But the essence of that is the same. It's like I get replacing one iPad or one Mac. I can support that. But if I go in the building, I say to the guy, yeah, you got to replace your 250 VAV box controllers plus your thermostats to get the latest and greatest functionality. And, you know, any one of us who's been in the space long enough, that argument died 30 years ago, you know.
Yeah, the dumpster retrofit, we used to call it, right?
It's all you guys on this call, all of them, all you guys that created this notion that stuff's gotta last for 30 years. So it's your fault, Anno.
It's literally true.
Well, there is a legitimate business concern there, right? When you go in, and why don't people do dumpster retrofits and so forth? And it does have to do with the cost of redeployment, right? I mean, you can get controllers now that are an order of magnitude more powerful for 50% of what you paid 10 years ago, right?
Less.
And I wanted to add too, the other thought that comes to mind, by the way, everything that's going on in all these other industries we were just talking about, cell phones, consumer electronics, all that kind of stuff, that is all, in my opinion, good for our industry, because it is making it much more acceptable and expected that, oh, your electronics are 5 years old, time for some new ones, right? I mean, when was the last time you had a cell phone for 5 years? So.
And the weird part is, you know, you could argue, one of the counter arguments I've always heard was, well, you know, when you get the new iPad, you get all this new, let's say a phone, like you get all this new functionality. Can I still make a call and do text messaging? Yes. Like the same thing that I did on the phone I had 10 years ago? Yes. Okay, what's the really compelling stuff? Well, you've got this really cute camera app and you can take some pictures. Is it any better than the camera? Yeah, it's a lot better picture. Okay, sounds cute. I'll do it, you know.
Yeah.
And we got the VAV. Well, okay, we've got to change it all out to this new. Well, what am I going to get? Well, we solved the VAV problem 30 years ago. So let me think about that. You know, what?
No, it's going to be 100 milliseconds faster.
Oh, that's right.
Yeah.
Yes.
I can control the temperature in my space, you know, 10 times faster than I could before. And that's part of the problem too, that goes with this.
Yeah.
I was just a funny side story. I was looking at a new TV over the weekend, and I was talking to the sales guy and trying to understand the difference between OLED and QLED and QNED and, you know, all those different things. And one of the things, you know, at the top of that is the OLED. It's the most expensive classification of TV, their display type. But the guy was very quick and proud to point out that some of the new TVs, you know, the OLED lasts more than 5 years now. You might get 7 or even, you know, 8 or 10 years out of that. And I was thinking, man, I'd pay 4 times more for a TV that lasts half as long, you know. So there's a lot of that here. Just the physical nature of our application, our industry doesn't require this super high performance stuff, right? And it always cracks me up. And, you know, I've talked a lot about doing work in restaurants and things like that, and a lot of retail stuff. And to this day, we'll go into retail applications and all these fantastic kind of modern high-end systems are being deployed to control, you know, 3 to 5 rooftop units. And I'm like, well, isn't that what a thermostat would do for each of those? You know, why are we putting these super high-end programmable controllers into this application? And it's just the state of the technology is the reason.
Because you can. Yeah, the answer.
Yeah.
Because you can.
Yeah.
Right.
Yeah.
So I'm wondering, as an industry, how much technical debt we're building here. And you know, because IP, you know, given the speed at which IP and, let's say, general computing is moving and improving, you know, I'm not sure I can think of what networking will be like in 10 or 20 years. And I mean, I don't think any of us would know whether that will actually create problems that we can't even anticipate. I mean, one of those problems is IPv6 and V4 versus V6, which is in itself has taken like 30 years to get very little, and you know, not really get solved because it's so complex. I'm just wondering what kind of technical debt would.
Well, it's the same question that Tracy just brought up. interestingly enough. I think the only difference is our time cycles, Anto. So like pneumatic controls, you know, technically there's a lot of technical debt in pneumatic controls, right? It kind of died when you couldn't find plumbers anymore, right? Who knew how a pneumatic thermostat controller actually worked. And that kind of got died out. It also died out as we brought the new technology in. You know, we needed less of the huff and puff guys to do pneumatic controls, right? So our cycles are a lot longer, though. That's the difference again, right? The cycle time. I'll give you another example, which I did a product management class years and years and years and years ago. It was a fascinating class. It was actually up at Sloan College there. And in the class, there was these two other guys. It was me. We were doing BAS back then, at CSI days back then, Anto. But there were two other guys. And one guy, he was a product manager for a bowling ball company. And the other guy was a product manager for some nanotech company. And we got into life cycle stuff. And the bowling ball guy said, my product life cycle is 25 years. The bowling ball technology changed once when they put the concentric weight inside. And then we just tinkered with it, and the nanotech guy was like, yeah, my life cycle was like weeks, in the product thing. So product life cycles matter in the space, and that's driven by market. And then, you could extend that, why isn't our life cycle faster? And to be honest, I think, one of the challenges we face is if we were building buildings like we used to at the rate, if we were building new buildings at the rate that we used to build new buildings, then I think absolutely our product life cycles would probably be shorter, right? Because as a new building comes out of the ground, there's an incentive for a new building to have, if you're building something new from scratch, I'm going to put the latest and greatest technology in place, and the market would be competitive to really have the greatest and latest technology in place. If I'm retrofitting an old building, yeah, we've had that discussion just now, not going to bother. But we don't build a lot of new stuff here in the US. When was the last time we built significant number of buildings at any rate? And now with COVID and the return to office, it's probably going to go backwards.
Yeah, it's interesting. Hey, there are a couple good questions that came up in the chat that I think we should talk about. Tristan brought up one about, are we also sort of implying that this is cloud, everything is cloud sort of architecture when it comes to IP? And I think the answer is still there's subtleties to this, and having things like your building needs to run when the internet goes down is still an important factor in this whole thing, but also can still be done with IP technology, technically, right? So that's an architecture question.
Yeah, that's a cloud issue, not an IP issue.
Yeah, and how you architect it, right? So
And that's why we created the IBB to partly deal with that.
And one of the things to just say out loud in this conversation is, I think historically everyone thought of cloud as a centralized architecture as opposed to a decentralized control, distributed control architecture. But these days, cloud is as distributed of an architecture as anything else out there, right? Between what you can do on site, with devices with web servers built into them, everything is its own little web server and own little cloud device at this point, right? So there are things that you have to pay attention to when you architect those kinds of things, I think.
And that's the whole thesis behind the cloud native architecture, is because it is the same regardless of where you are. It's kind of the way to think about it. And IP drives a lot of that as the networking.
Yeah, the infrastructure.
So guys, I referred to it in my earlier comments, and I would like to see us talk a little bit about it, which is when you deploy IP at the unitary, you're starting to deal with distances and infrastructure, networking infrastructure that historically you were far less concerned about. So RS-45 networks are thousands of feet, and you can daisy chain easily. And I am seeing people building in to their IP controllers or unitary controllers, the ability to daisy chain, but the distances are still a factor. And so I'm imagining, you know, we've got a world of, even though we're only 20% market share, that's still a lot of buildings out there with 485 networks. And if 10 years from now, I'm a building owner and I say, okay, you're going to replace these 20-year-old controllers. What are you putting in? Let's say, well, I want to put in IP devices. Well, what's going to be the challenge to hook those all up, right? Because they were wired with a 485. Can I use the same cable? Yes or no? In many cases, no, right?
Mostly no.
And yeah, so you got that challenge, and then you got the distance challenge. And sure, I mean, it's one thing to get yourself a new phone. You just go down to the store and you buy it, right? But if all we want to do is swap out one generation of controller with another generation of controller from a IP versus 485, there's a whole bunch of additional questions that we're going to have to resolve.
You know, and that's a very good point, and another factor to what's slowing this down, right? But I will say two things. One, in new building construction, one of the things that we're seeing as common practice is a very extensive IP network throughout to service, you know, computers and phones. And the need to have Wi-Fi everywhere in your building. So I can do a call, or I can have Wi-Fi in a meeting or whatever it might be. And what I've seen lately are some kind of novel approaches to solving the problem you're talking about. And I'll give you one specifically. The EnOcean Group, not the company, but that market set, has been working on a little technology that is a little USB dongle that plugs into virtually any switch or router or extender or any place where there's a USB port that's connected to the hardwired part of the system, and provides local EnOcean wireless coverage, right? Because EnOcean technology isn't a long distance technology by any means. And they're having success because companies and buildings have deployed Wi-Fi so widely, they just piggyback onto those routers. Right.
So I think that's a good way of responding to what I was going to say, is that what you said, Steve, is actually, again, it's not an IP issue, it's a physical issue.
It's a physical issue, right?
But what Tracy is illustrating is you can come up with new ways of doing the physical, and it's still IP.
Yeah,
correct.
So,
yeah, and I'm just saying, there's consequences to everything, right? So this is a known consequence, and we've got to get creative. And it sounds like EnOcean is helping in that regard. But certainly, Wi-Fi getting as ubiquitous as it is clearly a good solution as well.
Well, I think, Steve, couple that with you can get the chips with the Wi-Fi stack already all built onto the thing. It's not like you have to extend it anymore. So the cost of doing it at the edge is also significant.
It's negligible, right? Yeah. But so at that point, it's just, do I have good Wi-Fi coverage, particularly through mechanical rooms, through ceilings?
Yeah.
that's
So
fixable.
There.
Yeah, that's fixable just because it's physical.
But I think another driver here is the home automation and its dependency on Wi-Fi. And what it's done is it's put the capabilities, often far beyond our capabilities, in the hands of the masses. And so I think we're starting to feel the heat to move and think in that direction and act like we should. So there's a real ripple effect, I think, that's happening in the industry. And actually that was, I can go way back in when we first started the first DDC systems, and we started to use personal computers as the tool to work with those. That basically changed a lot of then we started getting computers in the buildings that weren't there to be computers, they were there to be interface devices. We're seeing more and more the phone is expected to be part of our system, so we have to work all that out.
Yeah, it brings up, you're right. Ken, and we've, like you say, we've seen this go through our industry every time that the home market brings in new technologies, new approaches, and that seems to be the impetus to get it into our space, because the facility manager brings his computer, brings his tablet, brings his phone, you know, to work, and goes, why can't I do it like I do at home? And so, you know, to your point, the home stuff.
I've said numerous times over the years, I've often viewed this adoption problem as generational in nature, right? And by that, I mean generational, like grandfather to son to grandson, you know, people coming, young people coming out of school these days. If you ask them, even non-technical people, would you expect your building to be internet connected? How many would say no? You know, everybody expects that now. So it's perfectly normal and natural to be designing systems that are deployed that way, designing systems that work on your phone, designing systems that are all IT, IP centric in nature. In fact, the stuff that we've done for the last 25 years would be really, why would you ever do that on anything new, right? That would be the approach I think that younger people in the industry would take. So it's
Scott made
Yeah.
oh, did he?
interesting comment. Science advances one funeral at a time. Yes.
Yeah, it's true. It's absolutely true. I mean, even basic
That's a great
stuff
quote.
like, and you've seen these examples over and over again, you know, babies who, you know, you put a magazine in front of them and they're trying to swipe, you know, the pages over, and you know, my kids, even who are in their 30s now, all grew up with cell phones, right? None of us on this screen had cell phones when we were teenagers at all, and they all did. So of course, that's the way things are going to look here
Yeah.
going forward. So I think the consumer side of things has the momentum there is just overtaken this. And
Yeah, it's, I mean, talking about IP, one thing we haven't discussed, and we probably don't have time today, is Matter. Matter is the standard that CSA came up with. And it's actually about IP. And the reason why Matter exists is that the different vendors of home automation systems, Google, Amazon, and Apple and others, were implementing basically different ways, different types of, or different structures of IP networks. And what Matter does is actually normalizes them into a single IP network. I'm sure I've simplified that too much, but I kind of wonder if Matter has a place in commercial buildings. And
So are you asking, does matter?
yeah,
well, there is work, movement, activity in our side of things to try to create a similar thing on the commercial side. We've talked about this, right? Getting organizations together to kind of create this sort of standard. And you bring up a really important factor to the adoption of all of this, which is there is a business cycle to this where for some window of time, there's an opportunity to be proprietary, invent your own technology, try to take over the market. But what we've seen is there's been no dominant winner here in this. So eventually everybody comes to the conclusion, if I'm going to achieve volume, I need interoperability, right? I need universal connectivity and interoperability, just like in the computer world. And I think our industry is starting to kind of see that time.
yeah, I think that to refine that a lot more, then you have to think about interoperability at different layers, right? Because in a way, something like BACnet is initially, anyways, now the more recent BACnet SC and others is actually further up the stack, but BACnet MSTP was a standard at the physical level, right? So all the standardization is actually creeping up the stack into the application layer, which is another conversation, which is not for today. So it's not just one standard that we need to, it's actually multiple standards.
Yeah.
And Tristan just sort of quoted Harbor Research as being everything, the arc bends towards interoperability, which is basically what we're saying.
Totally.
So any other sort of points that we haven't raised, either in support of or the
No.
other side?
You know, I've heard so much positivity on IP. And back when I was out there selling IP networks, you had all these people talking about something that's in the future, these flat networks, flatter networks where you're getting rid of firewalls and all that. And with all the positivity on IP, I mean, we haven't even gotten there. And then you've got a whole subset of people out there talking about how everything's going to get flat soon. And I'm like, not happening anytime soon.
Well, but that's the nature of IP, because it is inherently not secure. You have to build on top of it, right? And what you're talking about, and what Tosibox, which is obviously what you're referring to, is the various technologies that gets built on top of IP. So it's not really about IP, it's the management of IP, so that it can be secure, so it can be manageable. And that's a good segue to next week's conversation, which is really about management of networks, not necessarily just about IP. So that's good.
Well, that should be yummy.
So maybe Ken, I can ask you
Chocolate
to-
is yummy.
I'm with
Ken, do
you.
you want to do a
I'll
review
give it a
on
go.
what-
It's a pretty tough topic, but I think we did good. We touched on a lot of points that are inside of IP. It's definitely the trend of the future. We try to get our minds around it. The young people cannot stop. They can't separate it from their minds. It's just part of who they are. So that's just something, as we die out and as the herd thins out and the young bucks appear, the problem will be somewhat self-solving, I believe. We'll just see the new attitudes come. And what I always talking to my millennial elders now, and they talk about, you should see what these kids are doing now. And I think that's encouragement as well. And inside of clouds and inside of IP networks, you can do almost anything.
True.
That's where we headed. So, okay, great. Let us wrap this then. It's been a good conversation. And as I said, next week we'll focus on the management of networks, and hope everybody has a good week. And if you're in Vegas for Realcomm, I'll see you there tomorrow. If not, we'll see you back next week.
Okay. See you, everybody.
Bye-bye. Bye-bye all.
Bye.